This is a walkthrough of containers on the Google Cloud Shell, and I'm starting from the Google Cloud Platform Console dashboard page. And the first thing we're going to do is open up Cloud Shell, and the icon for that is in the top right of the dashboard. And the second thing I'm going to do is pop this out into its own window just so there's a bit more space to work with. And so we have a terminal and a shell prompt, and what I'm going to do now is start a container inside the host operating system, and just a really simple one. So I'm going to use the docker command. I'm going to use the run sub command, the --rm flag, which is going to cause the container to be removed when it finishes, the -it flags, which indicate that the container is intended to be an interactive container that I'm going to type commands into it. And then I identify the container image, which in this case is Alpine. And then when it fetches the image from the container registry, it starts executing the container, and we get a command prompt inside the container. So the number sign there is the terminal prompt or the shell prompt from inside the container, and this is separate from the host shell. And this is just your regular Linux bash shell, and so you can use all the usual commands that you're familiar with in Linux shells. So I'm using pwd to tell me what the current working directory is, cd/root to change to another directory. I can use the echo command to output content to a file in this case. And I can use the ls command to list the files in the current directory. Now, the next thing I'm going to do is I'm going to start up another terminal on the host. And I'm going to start another container with the same command. So docker run -rm or -rm -it alpine. And the first thing we'll note is I'm going to change to the same directory that I was in the other container, and I'll get a directory listing. And what you'll notice right off the bat is that the file that we created in the other container isn't present in this container. So the containers are totally isolated from each other. They have a separate file system. So a file created in one container won't necessarily appear in the other container unless they're sharing a volume, but by default that's not the case. So the file systems are separate. Now I'm going to start a third terminal on the host, and in this terminal I'm just going to get some information about the running containers. So right now I have 2 running containers, and I can get information about those by using the docker command, the ps subcommand, the -s flag, which is going to give me some size information. And I get a list of all the containers that are currently running on the system. So the container ID, the image that they're running, the command that they're running, when they were created, what their current status is. If any network ports are being forwarded, that would be listed in this column. The Docker client generates some unique names for each of the containers, and also in this case we have information about the file system size. So the number of bytes or kilobytes that have changed in this case, and then the overall size including the image. The other thing you can do is, so that gives you a snapshot of the containers that are running. There is also a utility that gives you kind of a real-time update, and so that is the stats subcommand. So it will be docker stats. And this shows you some similar information like container ID and name, but other information about the containers that are running, like how much CPU each container is currently using, how much memory each is currently using, how much network I/O, block I/O, and so on. And this is refreshed every so often, every second or so, and it's constantly running. And so to get out of that, I can just type Control C. And I'm just going to go back to, say, the second container and type Control D. So that is going to cause that container to stop. If I go to the third terminal window and do that docker ps command again, now you'll notice in the list there's only one container currently running. And that was because we specified the -rm flag. So when the container stops, or when we stop the container, it's removed from the system. And I'll go ahead and stop the first one as well. So Control D to get out of that. So now in all three terminals, I'm just back at the shell prompt on the host system. The next thing we're going to look at is working with images. So I can get a list of the images that are available on the current system by using the docker command and the images subcommand. And what we will see here is that there's just a single image, the Alpine image that we used in the previous two containers. If I wanted to get rid of an image, I could do that using the docker RMI. So RMI stands for remove image. And I can supply either the repository name or the image ID, and it will remove that image. So now if I do the docker images command, there are none currently on the system. The other thing I can do with containers, so I mentioned earlier that the containers are isolated. They have their own underlying file system. You can start up a container that mounts a directory on the host system inside the container. So we'll just do that now. The first thing I'm going to do is I'll make a directory that I'm going to mount into the container. So I'll use the makedir command, and I'm going to call the directory site1, and I'm going to go into that directory, and I'm going to create a simple web page in there. So put in some HTML markup. This is the first page. And I'm going to pipe that out to the index.html file. Okay, so we're in the site1 directory. It has a single file, index.html. And what I'm going to do now is start up a container, and I'm going to map the current directory into the file system of the container itself. So I'm going to use the docker run command as we did before, the -rm flag, the -it flag for an interactive session. The new flag I'm going to use is the -v flag, which mounts a volume inside the container. I'm going to identify the current working directory, so I'm going to use the $pwd environment variable. So that is the current working directory, the site1 directory that we're in on the host, and I'm going to identify the mount point inside the container. So colon and then the mount point inside the container. So I'm going to place this at /mount/site1 inside the container. And the other thing I'm going to do in this case is use the -u flag, and that sets the user ID and group ID. I just want to make sure that the user ID and group ID matches inside the container, the user ID and group ID outside the container, so that I don't have any problems with permissions of the files. So that is going to be user ID 1000, group ID 1000. And then I'm going to identify the image as we did before, so Alpine. And so now I get the prompt, the shell prompt inside the container. I'm going to go to that mounted folder. So I'm going to change directory to /mount/site1. We'll get the contents of the directory there. So there is the index file that I created outside the container, but that directory is mounted inside this container, and so it's available inside the container. I could also create files in here, and they would persist even after the container exits. So I'm going to do exactly that. So I'm going to make the second page. So this is the second page. And I'm going to redirect that to page2.html. And again, check the two files there, index.html, page2.html. And then I'm going to hit Control D to exit the container. And now if I'm back at the shell prompt in the host operating system, and if I get a listing of the files, you can see that second file that we created, page2.html, it persists outside of the container, so in the file system on the host, because we had mounted that directory there. So that's mounting volumes inside a container. Another thing we can do with containers is map ports from the host to a port inside the container. And so we'll do an example of that now. So I'm going to start up another container. So Docker, the run subcommand, the --rm to remove the container when it exits. Now, in this case, what I'm going to do is use the -d flag instead of the -it flag. So this is not going to be an interactive container. It's going to run in the background. I am going to mount the current working directory inside the container. And in this case, we're going to be using another container image, which contains the Nginx web server. And the Nginx web server expects the HTML files for the site to be located in a particular directory. So it has to be in the user share Nginx HTML folder. And I'm also going to pass in the RO flag to indicate that I want to mount this external directory read-only. So the container won't be making any modifications to that directory. The new flag we're going to be using is the -p flag, and that is used to forward ports from the host system into the container. So what we're going to do in this case is we're going to forward port 8080 on the host to port 80 inside the container. And we're going to run a different image in this case. We're running the Nginx image, which has the web server in it, and we're going to run the Alpine variant of that, so the lightweight version of that image. And it pulls the image down, it starts running, and then you'll notice I immediately am returned to the command prompt or the shell prompt on the host, and that is because we used the -d flag. So in this case, the container is running in the background. So if I do a docker ps, you will see that container is running in the background. It has its own ID, the image we specified. This is the default command for that image when it was created, its current status. And because we used the -p flag, we see that indication that port 8080 on the host is being forwarded to port 80 inside the container, and then the name of the container as well. And the nice thing about applications that are listening on port 8080 in the Cloud Shell environment is that you can preview them as a web application. So I'm going to go up to the web preview button in the top right of the Cloud Shell, and I'm going to preview the app that is running on port 8080. And what we end up seeing in this case is the contents of that index.html file that we created. And if I update the URL and put in the second file, so that was page2.html, then we'll see the contents of that page. So that's port mapping. And if I'm finished with this, which I am now, I can stop the container. So there is a docker stop subcommand. So docker stop. And we have to pass in the container ID of the container that we want to stop. So I'll just give that ID. And then, of course, if I return to the web preview page and I refreshed it, we've stopped the container, and so there's no web server listening on that port any longer. So we won't see the contents of the website. So that is mapping volumes and mapping ports. The next thing I want to demonstrate is creating our own images. So up until this point, we've used images. We pulled images from Docker Hub that have the the collection of code or whatever that we want to use. So we used the simple Alpine image. Then we used the Nginx image with the web server. We can make our own images. Typically, we make an image that is based off of a pre-existing image, and then we add to it. So that's what I'm going to do right now. And what I'm going to do is we're going to continue working in the Site1 folder. What I'm going to do is create a Docker file which describes the new image that I want to create. So in the Cloud Shell environment, I'm going to open up the editor. And I need to go into the Site1 folder. So there are the HTML files that we had previously, or we created from the command prompt previously. I'm going to add a new file at the top level of the Site1 folder, and we are going to call that Docker file. That's the convention for the file that describes a new image. And I'm going to copy and paste a couple of commands in there. And I'll just explain briefly what these commands mean. So the from clause identifies the base image. So we just ran the Nginx image directly a few minutes ago. We're going to build our own image based off of that. So the new image is going to have everything from the Nginx Alpine image. And then the second thing I'm going to do is I'm going to copy files from the current project directory into a folder inside the image. So that user share Nginx HTML folder, that is the root folder for the website. And what I'm going to do is copy all the files in the current directory. So that would be my index.html, my page2.html. I'm going to copy those into the container at that location, user share Nginx HTML. And then I'm going to go ahead and save that file. So Control S to save that, or from the file menu you can choose the save option. And then I'm going to go back to my command prompt, and now I want to build the container image. So that is the build subcommand for Docker. So Docker build, and I'm going to have to tag that image with an identifier. So I'm going to call this my website. And I have to indicate the folder that or the directory that we're building from. So I'm just going to use dot, which indicates the current directory. So I'm currently located in this Site1 directory, and that's where we're building the image from. And so the Docker command will go off and build that image. And so it executes those two clauses. So it's bringing information in from the base Nginx image, and then it's copying the contents of the current folder into user share Nginx HTML. And now if I run the Docker images command, you will see that image that we just built appears in the images list. So there it is, the my website image. And we can run that image, kind of like we've run other images. So I'm going to use the Docker, the run subcommand, and remove it. -D to run it in the background. I need to do the port forwarding, so port 8080 to port 80. And the image name I'm going to run is going to be the My Website image. And it goes off, and now that image is running again because of the -D flag. It is running in the background. So if I do Docker PS, we can see that image is running. And so if I go back to my web preview and refresh it, we should get the page back. Or that was page 2. I'll go back to the index page. There is the first page. So that image, the My Website image, is a complete self-contained image that contains the web server plus all of the files for that simple website. The other thing we can do with images is we can push them to a container registry, so we have a permanent record and we can reuse them later. I'm going to have to add another tag to this image, so we are going to be using the Google Cloud Platform Container Registry, and it expects the images that are going to be pushed and pulled from that registry to be tagged with an appropriate identifier. So I'm going to tag that image. So I'm going to use the tag subcommand. I'm going to identify the current tag for that repository, so My Website. And I'm going to specify another tag in the format that the Google Cloud repository is expecting. And so that's going to be, the host is going to be gcr.io, and then a slash, and then my project identifier. So for me, it's CPSC 2650. For you, it will be whatever your own project identifier is, and then the final tag. So I'm just going to use the same thing, My Website. And we can do Docker images again, and you can see that there's essentially 2 copies of the My Website image. The first one that we created, and then the second one. Really, these are aliases for the same image. They're just different tags. You can see the image ID is the same, and the creation time and the size is identical. So they're basically the same thing, just different tags for the same thing. But now that I have a tag for that image in the proper format, I can push that to the container registry. So I will use the Docker push, and I will use the tag in the appropriate format. So gcr.io/cpsc2650/my website. Again, if you were doing this on your own, you would use your own project ID. And then it goes off and pushes the image to the container registry. And just to convince yourself that that is going to work, I am going to remove my local copies. So Docker RMI, and I have to specify both tags there. Oh, oops. Oh, I'm not able to remove it, I guess, because it's already running. So let me just stop this container. Okay, so I'm hopeful that I'm going to be able to remove this now. So Docker. Okay, there we go. So Docker images And so you can see the image we created is completely gone. We just have the standard Alpine and Nginx images. So now if I wanted to bring that image back, I could use Docker run and specify the appropriate image, or I can use Docker pull just to bring it in without starting up a container. So we'll just do that so you can see the usage of the Docker pull command. So that is going to be Docker pull and whoops gcr.io slash cpsc 2650 slash my website. Just double check there. And now that is something I can run. So Docker run rm -d and forward the ports 8080 to 80 and the image name gcr.io slash and yeah, still working. And I'm going to go ahead and just stop that for the time being. Okay, so that's it for the basic Docker commands. So Docker run to create a container, Docker build to build a new image, and Docker push to push an image to a container registry, and Docker pull to retrieve an image from a container registry. The last thing we're going to do in this exercise is deploy a container image to the Google Cloud Run platform. So we're able to run these containers in the Cloud Shell environment, and that's fine for development or local testing. But these URLs, so for example, the web preview URL, that's not anything anyone from the public can use. It doesn't make the app accessible to the public. It's only accessible to us because we're logged into the Google Cloud Shell. If I copied this URL and emailed it to somebody and they tried to follow it, it would ask them to log in and they'd probably not have permissions to access the web application. So this is fine for testing or development, but is not fine for public deployment of a web application. So the last thing we're going to do in this exercise is deploy a container image to Google Cloud Run, which is designed to make our container images publicly available, or the execution of those images publicly available. So I'm going to go back to my home directory. And what we're going to do in this case, instead of a simple static website, we're going to create a simple Node.js, Express.js application. So I am going to use the Express generator app. So I'm going to run npx Express generator. And I'm going to use EJS as the view engine. And I'm just going to call this my app. And that is going to go off and generate the application. And I'm going to go into that folder and install the node dependencies. So npm install. And a couple other things I'm going to do are to modify the generated application slightly. So I'm going to go into the package JSON file. And there is a script for starting the application. I'm going to add a dev script for this. So a dev script that is going to run node mon instead of just node directly, but the same script. And the reason we're going to run nodemon is that's useful during development. It detects when source files changes and reloads and reruns the app on those changes. So I'm just going to go ahead and save that change. And now I'm going to go ahead and run the application. So you can see there is the suggested command to run the application. I'm not going to use start. I'm going to run the development script. And the other thing we have to do in order to use the web preview functionality, the application has to be running on port 8080. So I'm going to set that in the environment as well. So port 8080. Set the debug environment variable, and then run the development script. So the one that uses nodemon to detect changes to the source. So we'll let that go off. It's now running on port 8080. So if I go back to my preview tab, I should see kind of the Shell Express app. I can go back to the shell and let's open up the index page. And I can make a change to this. Just add another paragraph here. And go back to the browser. If I refresh that, then I get the refreshed application. Okay. So that's great where that application is working and running locally. I'm going to type Control C to stop that for the time being. Now, the end goal of this is to take this node or this Express application, turn it into a container image, and deploy it on Cloud Run so that it's publicly accessible. And so the first thing we're going to have to do is in the project folder, we're going to have to create a Docker file. So I'll make a new file. And we are going to have to fill that in with the commands to build up the image. And this is going to be a bit more involved than the previous Docker file, but I'll walk you through it. I'm just going to paste it in here first. And just to run through what's contained in this file. So the from clause, we need to identify the base image. So we are using a Node image, version 12 of Node, and the Alpine variant. That's the lightweight implementation of the Node application. The workdir clause identifies where we are going to deploy the application code to inside the container. So this is a path inside the container. And this does two things. It creates the directory inside the container if it doesn't exist, and it also sets our working directory inside the container as well. So then what we are going to do is copy the code from the local directory or the current directory on the host into the working directory in the container. So that's the purpose of the copy command. So this is going to copy package.json, and it's also going to pick up the package lock.json. So that is from the current directory on the host to the working directory inside the container. So dot just meaning the current working directory inside the container. So we need the package and the package lock.json files to get things rolling. And then we're going to run npm install to install all the node dependencies. And then finally, we are going to copy our application specific code. So dot meaning the current directory on the host, the other dot or dot slash meaning the working directory inside the container. So all of our scripts that are particular to our application, we need to copy that into the container as well. And then we need to identify what command to run when the container starts up. So we'll run the npm start command. So that's the contents of that Docker file. The other thing we are going to need to do for this application is to create a Docker ignore file. This copy command is going to copy everything in the current directory. We probably don't want to copy the development dependencies and things like that. So we are going to exclude that in the Docker ignore file. The first thing I'm going to do is I am going to turn on the hidden files view. So we end up seeing a lot more in the file browser, but I just want to make sure I'm able to view those files that begin with a dot. And then in the top level application folder, I need to make a new file, and this is going to be the Docker ignore file. And I'm going to put some lines in there. So in the container, we don't need the Docker file itself. We don't really need the README file. It's not important for the execution of the application. What we really don't want is the node modules folder. We don't want to make that part of the image. We want, when the image is built, to use npm install to only pull those dependencies that are required for the execution of the application. We don't necessarily want all the development modules as well. So we will exclude the node modules from the copying, and also npm debug if it exists. So if we've been developing locally and there's an npm debug log file, we don't really want to copy that into the image either. It's not necessary. So I'll go ahead and save that file, and then I will return to the shell. And now we can go ahead and build the image. So that's Docker build, and we're going to tag it. I'm going to tag it right off the bat with the proper tag for the Google Container Registry. So that's going to be gcr.io, and my project ID, and the name of the application. So we'll call it my app. And we are going to build from the current directory. So dot indicating to build the image based on the Docker file contained in the current directory. And there we have it. The image is built. If I run Docker images, I can see it right there. So there's the My App image. And did I stop this? Yeah. So the web preview, if I refresh the page, it doesn't work because we stopped the dev script from running. Before we run this in Cloud Run, it would probably be a good idea to test it locally. So we'll use Docker run. Again, we'll remove that when it finishes. The extra thing we're going to need here, so a new flag for Docker, we're going to use the -env flag. And the reason for that is we need to identify to the image the port that the application needs to listen on. So that is going to be port equals 8080. And let's run this interactively. Even though we've specified the port environment variable, we still need to do the port forwarding from the host to the port inside the container. So we will forward from port 8080 on the host to port 8080 inside the container, and then we will specify the image. So gcr.io/cpsc 2650 and my app. And then I think that's all there is to it. It should be running. So if I go back to the web preview and refresh, I get the index page for the application. So I'm confident now that everything is working. So Control C to stop that. And so that looks good. So I can push the application to the registry. So Docker push gcr.io CPSC 2650. And again, you would be using your project ID if you were running through this exercise, and then my app. Good. And so now we have a copy of the image in the Google Container registry. So the last step of this exercise is to deploy that image to Google Cloud Run so that people can view the application publicly. So I'm going to go back to the Google Cloud Platform console. I'm just going to close this and go to the Compute Cloud Run console. And what we are going to do is create a new service. And I am going to identify so we're going to select Cloud Run, the fully managed variant. I am going to choose US West Oregon because it's closer to where we are. I will give the application a name. I will call it My App. And an important piece to making the application publicly available is to set the authentication appropriately. So I'm going to tick allow unauthenticated invocations. So in order to access this app, we don't need people to be signed in to their Google account or anything like that. It's going to be a public website, so we want to permit unauthenticated invocations. And then we'll go to the next page. And we have to pick the container image that we are going to use. And so the one we want is the one we just created, the My App image. So we can select that and continue, and then click on the Create button. And this will take a little while to set up. Shouldn't take too long, but we'll just wait for that. And there it is. And so you get some information about the deployment. The important piece for us, though, is the public URL for the application, and so you can see it right there in the header. It's hyperlinked, so you can just click on it, and that will run the application. So now, in this case, the application is running in Google Cloud Run. This is a URL. I mean, it's not very pretty, but we'll see how to fix that next week. But this is a publicly accessible URL. It's persistent. It's going to run continuously. This is a URL I could share with anyone, and if they typed it in their browser, they clicked on it in their browser, then they would be able to see our application. Okay, so that pretty much concludes our introduction to containers on the Google Cloud Shell and also deploying container images to Google Cloud Run.